Forget all the guesswork. Today, we are cracking the code on the A-level physics paper 9702/12 for the March 2026 session. Now, this isn't just a hunch. This is a definitive prediction built on years of statistical patterns and a really deep dive into what examiners are actually looking for. Let's get right into it.
All right, let's be honest. It's time to stop guessing what you need to revise. Based on the big syllabus shift after 2022 and, well, the predictable habits of examiners, we're about to lay out a crystal clear strategy for the 40 questions you are almost guaranteed to face. Okay, first things first. You have to understand that this exam isn't random. Not at all. It follows a very strict, repeating blueprint. And just knowing this structure, that's your first big advantage. So what should immediately jump out at you on this slide is the sheer weight of one single section. General physics, mechanics, forces, energy, it makes up a massive 50% of the entire paper. We're talking 19 or 20 questions. Mastering this block is absolutely foundational if you want a strong grade. Think of this slide as your roadmap for the exam. Seriously, questions 1 to 4, they're always going to cover your basics in physical quantities. Then you dive headfirst into that huge general physics block. After that, it's waves and superposition, then electricity, and finally particle physics wraps it all up. You can literally walk into that exam hall knowing exactly which topic is coming up next.
So, how does this structure actually help us predict the questions? I mean, knowing the blueprint is one thing, but knowing the exact concepts they're going to test, that's the real goal. So here are 5 questions you can practically bet on seeing in March 2026.
First up, a real classic opener. You can pretty much guarantee that one of the very first questions is going to test your ability to make a reasonable estimate of some physical quantity. The key here isn't precision, it's about knowing your orders of magnitude. They're testing your physical intuition. Is the weight of a person closer to 70, 700, or 7,000 newtons? Just knowing it's around 700 newtons gets you the mark. Okay, prediction number 2, this is a calculation that consistently, year after year, trips students up.
We are talking about the propagation of uncertainty. And trust me, this is a classic trap, especially when it comes to free-fall experiments. If you're calculating the uncertainty for g, you have to remember that the time value is squared in the formula. What does that mean? It means you must double its percentage uncertainty. Forgetting that one simple step is such a common way to lose an easy mark.
Our third prediction, this one involves comparing forces. Examiners just love asking you to compare the upthrust on an object on Earth versus, say, Mars. The key is actually really simple. Upthrust depends on the weight of the fluid that's displaced. So less gravity means less weight, which means less upthrust. The ratio of the upthrusts is simply the ratio of the g values.
Prediction 4. Now this one is a staple of the new syllabus, so pay close attention. It is all about polarization and Malice's law. This is a straight-up application question. They'll give you an initial amplitude or intensity and then ask what happens when a polarizing filter is rotated. Now, don't get caught out. Make sure you know whether the question is asking for amplitude, which uses cosine theta, or for intensity, which uses cosine squared theta. It's a simple plug-and-play, but you've got to know which formula to use.
And finally, our 5th high-yield topic. This one comes straight from the source.
Yep. This comes straight from the examiner reports, which consistently highlight quark composition as a major area of confusion. So let's be absolutely clear on this. Hadrons are particles made of quarks. Baryons, like protons and neutrons, have 3 quarks. Mesions have 1 quark and 1 antiquark. You should expect a question asking you to identify one of these, or maybe even describe a quark change during beta decay.
Now let's talk about what might just be the single most effective revision strategy you can use. See, examiners don't reinvent the wheel every single year. They reuse concepts, and sometimes they even reuse entire questions. We call these the conceptual twins.
This right here is your secret weapon. You need to focus on the most recent papers, especially from the 2024 sessions. Why? Because you can expect to find 3 to 5 questions that are basically clones of questions from recent years. It's true. Examiners test the same concepts over and over. Mastering these past papers is like getting a sneak peek at your actual exam.
Okay, so we've covered what will be on the paper, but knowing the questions is only half the battle, right? Now let's focus on how you should approach it to maximize your score and avoid those classic traps that cost students marks every single year. Let's start with Newton's third law. The classic trap here is thinking that force pairs act on the same object.
They don't. Think about it. The Earth pulls on a box, and the box pulls on the Earth. That's your force pair, acting on different objects. And just as important, they must be the same type of force. Don't mix up gravitational and contact forces. It's a guaranteed way to lose a mark.
And for your calculations, these 3 points are absolutely vital. First, convert all your units to their SI base units before you even start plugging numbers in. Second, be meticulous with your powers of 10. A tiny slip here can change your answer by a factor of 1,000. And finally, always show you're working. Even if you get the final answer wrong, clear steps can still earn you partial credit.
Finally, let's talk time management. Look, don't just work from question 1 to 40 in order. Instead, use the round trip technique. On your first pass, go through the whole paper and answer every single question you know instantly. This builds momentum and banks those easy marks. Then, on your second pass, you can use all that time you've saved to really dig into the tougher, multi-step problems. This is how you optimize every single minute of the exam.
So that's your game plan. If you only do one thing tonight, make sure you are fluent with your SUVAT equations for kinematics and the potential divider rule for circuits. They are guaranteed to show up and they will be useful. Good luck.
You now have the blueprint, you have the high-yield topics, and you have the strategy. The only question left is, are you ready to turn these predictions into points?